For part two, we're going to pick up where we left off with part one. So now we are looking at this example. Choose a scatter plot that best represents the relationship between the age of a car and the amount of money spent each year on repairs. Okay? So we need to figure out, okay, what makes sense? So first and foremost, does it make sense that there are going to be any cost of repairs when your car is less than 0 years old or 4 years before your car is even made? No, that makes absolutely zero sense. Before the car is even made, there can't be any repair costs. So we are going to eliminate that as an option. Now we're looking at two graphs. We have one where as the car gets older, the cost of repairs increase, and one where as the car gets older, the cost of repairs decrease. Okay, so here we have our increase, here we have our decrease. So we have to think about what makes sense. Okay? When you first buy a car, okay, think about if you went out and bought a brand new car. Are you going to have to pay a lot of money to maintain that car in the first couple years? Hopefully not, because everything should be running smooth. Remember, it's a brand new car. Everything should be good to go. Nothing should be wearing out right away. So your maintenance costs should be pretty low if you had a brand new car, okay? So here we have low costs, but here for the first few years we have really high costs. So again, it's just not gonna make sense for C to be the answer, because when you have a brand new car, you're not gonna have a lot of repair costs because things aren't falling apart. So that shows us that our option that's left over is B, okay? And when it says explain, how we want to explain that is kind of what I said as I was talking. A car cannot be negative years old, and a new car will have low repair costs. Next problem. Again, we're going to choose a scatter plot that best represents the situation we are given. Here we're looking at the number of minutes since a pie has been taken out of the oven, or you could think about really anything that you take out of the oven, and the temperature of that item. Okay? So again, we want to think about, okay, what's different between all these three graphs? Okay? Graph B, we've got negative time. Graph A, we've got negative correlation, and graph C, we've got a positive correlation. So first, let's look at this negative thing, okay? Is anything going to start cooling down in the oven before you take it out? No, nothing is going to cool down inside the oven before you take it out. So we can eliminate graph B. For graph A or C, we have to think, okay, are the temperatures going to decrease the longer it sits out, or are the temperatures going to start low and increase as the item sits outside the oven? So take the item out of the oven, what immediately starts happening? Is it heating up or cooling down? It's cooling down. So here we can eliminate graph C because that one is increasing. So we have our answer of graph A. And again, we can write a short explanation, okay? So first thing is nothing cools while still in the oven. And then we eliminated graph C by saying things cool down when taken out. So there's our explanation of why we chose graph A. We've got just a couple more examples here. Our next example, we have based on the trend line, predict how many wrapping paper rolls need to be sold to raise $500. So here you see money raised and rolls sold. Okay? So we want to raise $500. So we're going to look at the money raised part and find where would $500 be. Okay? $500 would be about right here, halfway between 400 and 600. Okay? So we are going to draw an arrow over to our graph at about $500. From there, we want to know at that point on my line how many rolls need to be sold. So I'm going to draw a line straight down to figure that out. So now I've got my line straight down. I just have to figure out what is that point. What is halfway between 50 and 100? Halfway between 50 and 100 is 75. So I have to sell 75 rolls in order to make $500. Let's take a look at our final problem. The scatter plot shows a relationship between the total amount of money collected at the concession stand and the total number of tickets sold at a movie theater. Based on this relationship, predict how much money will be collected at the concession stand when 150 tickets have been sold. So here's how many tickets are sold at the movie theater, and here is how much gets spent on concessions or snacks and food at the movie theater. Okay, so you can see as more tickets are bought, we're seeing more money is being spent at the concession sales. Okay, you can see that our data only goes to about 60 tickets being sold, so that's where we are making predictions with how much would be collected at 150 tickets being sold. So first we want to figure out where on my graph would 150 be. I can see I'm going up in 20 increments, 20, 40, 60, 80, 100, 120, 140. So this is 160. So I know that 150 is going to be halfway between 140 and 160. So I'm going to put my line in about halfway between. Once I know what point on my line I'm looking at, now I can draw a line to the left to see how much money that would get me. So I can see that I'm about halfway between 800 and whatever's below 800. I can see that because every other one is labeled and it's going by 200s, that the lines are actually going by 100. So I actually have, this is 100, 300, 500, 700. So I'm at about halfway between 700 and 800. So what's halfway between 700 and 800? $750. So I'm making my prediction, if the theater sells 150 tickets, they'll make $170, they'll make $750 on concessions. So that is how you can make predictions using a scatter plot. So the big thing I want you to remember, in positive correlation, the value of the variables tend to go in the same direction. Okay, so if one increases, the other increases. In negative correlation, the opposite is true. As the values of the first variable increase, the second one decreases. Okay, and again, remember that's kind of like when we were looking up here. We have graph B is positive, graph C is negative. Here, graph A and B are negative, where graph C was positive. Okay. Are there any real-world examples of each type of correlation that you can think of? What are things that both increase at the same time? Or what are things that increase and decrease? For example, is there anything that as time goes on would increase, or anything that as time goes on would decrease? Those are kind of the easiest things I could probably think of. This is the end of your notes for scatter plots. Have a wonderful day.